All right, so today I'm going over Math 20-2 workbook, the workbook for section 5.5, and I will be covering questions 3, 5, and 8 in this recording. So for question number 3, you're asked to determine the percent of data between each pair of z-scores. So I'm just going to show one of those, and then hopefully that will give you the general idea of how to work through these. So we're given a z-score of negative 2.12 and another z-score of negative 1.33. So basically what you want to keep in mind is, like if we think about our normally distributed curve, kind of like that, what we're looking at here with the z-scores is if this is our mean, and then we have, minus 1 standard deviation, 2 standard deviations, 3 standard deviations, we're looking for negative 2.12 standard deviation, so kind of like somewhere pretty close right after here is what we're looking for, and then about a third of the way past the negative 1 standard deviation. So essentially we're looking for what a percent of the total area under the graph is represented by this part. Now remember our z-scores, when we look up the values associated with these z-scores on the table, those values are telling us what percent of data falls to the left of these values for the standard deviation. And so if we want to figure out what percent lie between two specific points, we need to find the difference between the percent that's to the left of the 2.12 and the percent that's to the left of 1.33. And then the difference between those two values is the value that we find in between them. So if we solve for the negative 2.12, we go to our table. Sorry, the glare on here is pretty bad. Negative 2.12. So we want to go across to the 2, so negative 2.12 to solve for our 100th spot, right? And we get 0.0170. So for negative 2.12, we have 0.0170. And remember, in order to make that into a percent, we multiply it by 100 to give us 1.7%. We do the same thing for negative 1.33, so we have negative 1.3, and we need to find 0.33, so that's going to be 0.918. And of course, if we multiply that by 100 to make a percent, we get 9.18%. And then, like I mentioned, because we're looking for the percentage of data that falls between these two ranges, and these are giving us the information of how much is to the left of each, we're going to do 9.18% minus the 1.7%, which gives us 7.48% of the data for this curve is between negative 2.12 and negative 1.33. Okay. Question 5 is a little bit trickier. I'm not sure if I can see about, so I'll just put the question up here for now. So a vinyl tile manufacturer produces floor tile that has an average thickness of 5 millimeters, so we're given the mean, and it has a standard deviation of 0.2 millimeters. With premium floor tiles, the flooring has to have a thickness between 4.8 and 5.4 millimeters, and we want to figure out what percent of the total production can be sold as premium tiles. Okay, so basically we're looking for what percent of the tiles have a thickness within this range, okay? And we're assuming a normal distribution for that. So I'm going to start out my question by, just kind of keeping track of what information I've been given. So I was told the mean was 5 millimeters. My standard deviation was 0.2 millimeters. And my range for the premium tiles was 4.8 to 5.4 millimeters. Oops. And so we want to know, basically, if you want to figure out percentages, you're always looking for the z-scores. So just like we did in the previous question, if we want to figure out what percent fall within this range, we need to figure out which z-scores are associated with these measurements, and then find the difference between those two. So essentially, I'm just going to use my formula for the z-score, z equals x, which is your data point, minus your mean divided by your standard deviation. So I do that for both of these. So 4.8 is the one I'm solving for first here. So in order to solve for my z-score, I have to use my data point, which was 4.8, minus minus my mean, which is 5, and then divide it by my standard deviation, so 0.2. And when I do that, I get -1. Okay, and then do the same thing for 5.4, so basically solve for the z-score. So in this case, we have 5.4 as our data point, subtract the mean of 5 and divide by the standard deviation of 2, and that gives us a z-score of 2. So now we also want to know the percentages that are associated with each of those. So for -1, just make sure you're doing the -1.0, but remember that the 0 is at the far side for the negative chart. So it's going to be 0.1587. 1587. So that's 15.87% of the data is to the left of -1. And then for 2, flip over to the positive side, 2.0, in this case the 0 is on the left side, so it's just the 0.9772. 9772, which translate to 97.72% of the data. And so again, just like we did in the previous question, we want to figure out what percent of the data is represented by these values. So we need to find the differences between those percentages. So we basically just go 97.72 minus 15.87, which leaves us with 81.85% of the data. So we can round that off to 82%. Are fit within that range. Okay. Okay, then question number 8. I'm wondering if I can just make this a little bit smaller and keep it in this screen. Sorry guys, just give me one sec here. Now it's all scrolled off on a weird area. I'm just going to bring it over into our shot here. 5.6, there we go. Okay, so, I don't know, maybe I'll try and keep this down here because we need to have this data. Hopefully it's not too small for you guys. Doesn't seem like expanding it is helping it much. So basically, Tyrone is considering a career in business because he does well in accounting. He also does well in chemistry and has thought of becoming a chemical engineer. The marks for both of these subjects in all classes at his school are normally distributed. So first we want to determine the z-score for each of Tyrone's marks. So this one should be pretty straightforward because basically you are just filling in your formula for the z-score there. So z-score for the first one is going to be equal to his data point. So if we do accounting first, his data point is that he has 90% in the course, minus the mean, which is 75 for the class, and then divide it by the standard deviation, which is 5.2. And that gives us 2.884, kind of like an ongoing decimal there. His z-score for chemistry is going to be, his data point is 92, because that's the mark he got, minus the mean, which is 78 for this class, and divided by the standard deviation, which is 6.1. So when we do that, we get 2.295 and another extended decimal there. So the first one was just figuring out the z-score, and then it says in each subject what percent of Tyrone's peers have marks less than his. So this one's nice and easy because unlike the previous questions where we're looking for a difference between them, in this one we're just looking for the percent that's lower than that. So we literally just have to look on our z-score chart. I don't know why I keep saying that. Z-score chart to figure out the percent that's lower than those two z-scores. So just round it to the nearest hundredth because that's that's all we have on the Z-score chart. So in this case, 2.884 is going to round to 2.88. So we can go here and look at 2.88 is going to be 99.80%. Okay, I did the conversion right away, like it's 0.998, but we know that we have to multiply that by 100 to get the percentage. This one, just be careful here because we have a 5 as our last digit, so we want to round it. It's not going to be 2.99, it's going to be 2.29, it's going to be 2.30. So 2.30 is 98.93%. Okay, so basically in accounting, 99.8% of the students have a mark less than Tyrone, and in chemistry, 98.93% have a mark less than Tyrone. So then the last question says, which subject is Tyrone better in relative to his peers? Well, he has to be the one that he would be best in is the one where more of the students are getting scores less than he is or grades less than he is, and so that would be accounting. So for C, we would say accounting. And if you guys were doing a written question on a test, please explain that, right? So give the explanation that because a greater percentage of his peers had marks less than he did, his score relative to his peers is best in accounting. Okay, so that's everything for 5.5. Hopefully that helped, and I will see you next time.